Okay, continuing with our Sprite Manager script, in this video I'm going to take our animation and put it in the lower left hand side of the screen. So we're going to look at the screen resolution because your audience will obviously use a range of monitors and those monitors will have different resolutions, so we need to kind of adjust the camera to match the resolution of the monitor. So we're going to do that in this video. And to do that we're going to use an orthographic camera. Okay, so once we set that up, you can use that camera to just display sprites, and these sprites will be the GUI layer, the layer which we display information about the game. So the orthographic layer is going to overlap the projector layer. Okay, so the camera that displays the 3D objects in the game. Okay, so let's get started. I'm going to create another camera to start with. Game object, create camera. And this is going to be our sprite camera. So it's going to display all of our 2D sprites in the game. In this case it's going to be our loading sign. And we want to change a few things here. We don't want to display a skybox or solid color when the clear flags are met. We just want to do depth only. But we don't want to display everything in the game. We just want to display sprites. Okay, so I'm going to create a new layer here. I'm going to call it Sprite. Okay, simple as that. And we only need to change the layer for our Sprite Manager object because this is where the sprites are created. This is where they originate from, the Sprite Manager object. So yeah, it's on the Sprite layer. Put it on the Sprite layer. And we don't need to change the client layer because we just use the client to draw the sprite on top of. You know, the actual sprites come from the Sprite Manager. That's why it's really important to zero it out and don't change the scale and stuff. Okay, so within our main camera we can say I want to display everything apart from sprites. So we can say everything, so do you want everything, untick sprite, and now it's mixed, and now it displays everything apart from sprite. Okay, so we don't display any of these 2D sprites in our main game, we just want to display it on the screen on our sprite camera. So going back to our sprite camera, we need to configure this. We need to change the culling mask to nothing and then change it to sprite. We only want to display sprites with this camera. And the projection, orthographic, because we want it to be kind of 2D, we want everything to be flat. Okay, and we don't need 1000 as the file clip plane, we can just have like 50 or something like that. So we can fit all of our 2D sprites within this space. It can be even less than 50 actually, but it doesn't really matter. The size is not important. We're going to change the size in our C# code so it matches the screen resolution. Okay, so if we go to code the sprites width and the height in world space, we can actually use the pixel value of it. Now that's really awesome. So instead of guessing the width and the height of a sprite, we can just change it to the pixel value. Might want to make it smaller, but it's up to you. And that's all we need to do here. The depth. We want to change the depth to 1. This camera is going to overlap our 3D camera. Our 3D perspective camera, is depth 0, and our sprite camera is depth 1. Okay, guys. So moving on in our script. Firstly, I want to talk about screen resolutions, and Unity stores screen resolutions in the screen class. So we can say screen resolutions. And this is really clever. This is an array and it stores all the resolutions available on your monitor. So we can say I want the resolution at index 0, which will be the smallest resolution. So firstly I'm going to loop through all the resolutions and see which ones are available on my laptop. So for int I equals 0, I is less than screen resolutions length, I++. We can then debug log each of the resolutions. Screen resolutions at this index, and a resolutions object stores a width and a height. So we can say the width firstly, and then we can say I also want to display the height. Okay, just a quick test to see which ones are available to us. So let's play. Let's generate the debug statement and quit the game. There's 2 audio listeners in the scene, I forgot to do that. So by default every camera created has an audio listener unless you do it through code. Let's remove the component on our sprite camera, and I've only got 1 audio listener. So here are the screen resolutions. The lowest one available is 640 by 480, and on my laptop there's 10 available, so it goes right up to 1440 by 900. Okay guys, that's why the YouTube videos up till now are in 720p. If it was any higher, it would probably be 1080p, so sorry about that guys. Okay, so these are our resolutions, and to start with I'm just going to use 640 by 480. Okay, so if I quit this now, we can make a new field in our class. We can call it a public. So I'm going to put the camera first. I'm going to put Sprite camera, and then we can say a private resolution. There's a resolution object, believe it or not. Resolution, we'll call it screen resolution. So if we dive into my script, I'm just going to drag the Sprite camera onto this so we can refer to it. Okay, so we don't need this anymore. We know the resolution's available to us, and I'm going to say screen resolution equals screen resolutions at index 0. This will be 640 pixels by 480 pixels. Okay, so if we go to the scripting reference on the screen class, we can see the resolutions, and as you can see, it's a read only. We can see the resolution, and it's got a width and a height value. Okay guys, and the lowest one's 640 by 480. So now we've got it. Okay, this is the resolution set. This is the resolution. We can now set the resolution. So to do that, we can say screen set resolution. Boom, let's go back to the scripting reference, and there's only one function in this class, and it's set resolution. So we need to bring in the width, the height, and whether it's full screen or not, and preferred refresh rate, not very important in this video. So I'll say screen resolution dot width from this object here, screen resolution height, and then false. I'm not going to run it in full screen. Okay, so we've set our resolution. That's awesome. And now we need to adjust the orthographic camera size to match that resolution. So it needs to be, you know, the same aspect as the screen resolution. So then we can display all of our sprites on the screen within the orthographic camera. Simple as that. So we can say sprite camera orthographic size. Okay, so I'm going to stop right there. Orthographic size. Let's dive into the manual. Okay, so the orthographic size is the camera's half size when in orthographic mode. So this is the half of the vertical size of the viewing volume. So it's half of the height of the camera. So the height divided by 2. Simple as that. So we can say the sprite camera orthographic size equals screen resolution height divided by 2. Because we want it to be the same height as the screen resolution, and the orthographic size is half of that size, so we just divide this by 2. And the last thing we're going to do is just move the camera into a place in our scene so we can refer to it. So I'm going to say sprite camera transform position equals new vector 3 0 0 and minus 100, because I'm going to move it back. So let's go back to our scene now. So I'm going to play this game. I've collapsed the game in the scene view so we've got more space so we can see it better, and as you can see, it's adjusted the size of the orthographic camera so it matches the screen resolution, and that's really awesome. Now we can actually place the client object, and as you can see, we've worked out the resolution stuff before we've drew the animation and stuff, because if we'd done this afterwards we'd have to move the client object, and we've just done the sprite sheet, the sprite manager class. We haven't put the linked sprite manager class, so if we move the client object the sprite would not move with it. And I guess it's common sense really to declare your resolution before you move anything in the screen, just the way things go. So we can say here, after screen resolution is determined, we can then set up the animations and GUI in general, so user interface, and that's all we need to do for the start function, I think. So let's go into our draw co-animation, and I'm going to position this client object straight after we've found it in the scene. Okay, so I'm going to position the client object at the lower left hand side of the orthographic camera, so it's going to be here. Okay, so in our game we'll be able to see it at the lower left hand side no matter what resolution it's on. So to do that, all we need to do is say client transform position equals new vector 3, and for the x value we can say, well, sprite camera transform position dot x, because let me explain something here guys. If I jump into the game, Okay, so the camera's transform is right in the center of the orthographic like view, the size of it, so it's right in the center. So the actual view sits in front of the camera object. So to work out the position of the sprite, we can say, well, we want to go back half of the width, we want to go down half of the height, and the z value, well, we just want to push it into the near clip plane. So as long as the z value is more than 0.3 of the camera's position, then it will be inside the screen space. So that's the way we're going to work this out. So camera transform x minus screen resolution dot width divided by 2. We want to move it back half of the width. Okay, similar here, sprite camera transform position dot y, and we could say screen resolution dot height divided by 2, but we can do something simpler than that. We can say sprite camera orthographic size, because that's half of the height. We just looked at that in the scripting reference. We can go down half of the height, and for the z value we can say again sprite camera transform position z. Okay, but this time we're going to move it forward into the near clip plane, so then we can say plus sprite camera near clip plane, which is 0.3. But if we just rest it right on the near clip plane, it will not display. We need to put it in actually inside the actual view, so we can say +1. Alright guys, so simple as that. We've moved the client into position, then the sprite will be drawn into orthographic position. Then we can say add sprite. Boom, done. Okay, so I think that's all we need to do, and actually there's one more thing. We need to change the width and the height of the sprite itself to the actual pixel value, so we can say 80 pixels maybe that would look good. We could say 128, the actual value with the way we rendered it out, but I think 80 will be fine in this case. So if I build the game now, it's going to be 640 by 480. Okay, we've set the sprite, the orthographic camera to the same size as the screen resolution, and then we move the client object to the bottom left of the orthographic camera, and the orthographic camera's content, or the sprites, are going to overlap the perspective camera. Let's build the game, see if everything works. Firstly in the 640 by 480. So build this. I might have to skip the video, skip this bit in the video because it might take a while. Okay, I think it's done now. Let's go into our build resolution test. Let's play this game. Oops. So no matter which resolution I choose to begin with, it doesn't matter because it's going to default to 640 by 480 when we first start our GUI script. So let's play. Okay, so it's the big one, then it goes down to the small one. And our sprite is showing at the left hand corner of the screen, and that is awesome. But before we move it into place, before we move it across a little bit and then up a little bit, I'm going to test if this works on another resolution. So let's make a really big one now. So I don't know which one this is going to be, but I'm going to use the resolution at index 5. So the biggest one's index 9 because there's 10 altogether. So if we go to index 5, it should be a lot bigger. So this is no longer 640 by 480 because it will be the biggest, bigger one. So I'm going to build it again. Resolution test, replace. Okay, we replaced it. Let's run the game again. And it doesn't matter which one we choose. Let's play. Bam, bigger this time. Exactly the same thing happened. The sprite is at the lower left hand side of the orthographic camera. So not only can we display the graphic in the world pixel, the right pixel values, we can also display it anywhere on the screen, no matter which resolution we're running at. So to finish off this video, I'm going to move it inwards a little bit, and that's really simple to do. I'm going to go back. So we're going to move it to this position, and I'm going to plus, I don't know, half of this width, so we can say 40. Actually, I'm going to put the whole value plus 40, so 120, and I think I should do it in the X as well. So plus 120. Okay, so this should work. I'm going to run the game one more time, build it again. Resolution test. Okay, let's run it again. Play. Oh, that's better, isn't it? So it's gone in 120 units from the side. So that's it, guys. That's what I wanted to do for this video. So if you were loading something from, I don't know, within the game, maybe we're loading an asset bundle or something, then this could show up and it plays really nicely, pretty smooth. So well, pretty smooth for my screen recording software anyway. And that's how we do it, guys. So I'm going to quit this now. Another way we can edit the position of the sprite is to change the offset. So the offset is vector 3, 0. We could change the offset if we wanted to. So the 0, 0, the origin, is not in the center of the sprite. It could be anywhere. Okay, so I'm going to leave it there for this video. And as a side note, you might want to make it so the lower the resolution, the smaller the image, because the image is going to take up a lot more of the screen space if it's on a low resolution. Okay, guys, so you might want to store these in variables and then see what the resolution is and then make them a bit smaller. Just a thought, because if you're running at 640 by 480, that loader graphics is going to take up a lot of the screen, so you might want to do something about that. So I'm going to leave it now for this video. Thanks for watching, guys. I'll hopefully see you in the next video. Thanks a lot.